Hello, YouTube students and Covalence students that are trying to learn how to do server-side development from this one walkthrough. Welcome back to this little video series. I filmed the last video before Thanksgiving, and I intended to film more, but I never got around to it, so this is me picking up from where I left off. Almost a week after recording the very first video, so things will probably be a little bit different on screen here because I might have a different editor windows open, but I rewatched my previous video to see where I had left off to pick up this discussion here. As always, watch the first 10-ish or less minutes of the first video. If you are coming upon this and you don't know what we're doing here, this is part 2 of this video series that is meant to teach the fundamentals of server-side development, basics of testing it, and how to finally connect it to a front end. So while this doesn't include a database, we do have a JSON file we are reading in and out of. And the purpose of it is to act as our database. So while this isn't technically the full stack, it is pretty much the full stack with a JSON file instead of a database. Totally valid solution for small side projects. But again, the point is here that I'm trying to just bridge a gap that some students seem to sometimes overlook at this portion of our full stack course, which you have interest in learning any kind of front end or back end development or any kind of beginner to advanced React information, then check out a link in the description down below for our community membership, which for $25 a month, you get access to our front end and back end courses. Combine them, that is our entire full stack program. It's a lot of content. And then I also have a standalone React course that I made that takes you from zero to hero that I'm continually updating. I'm also adding new courses coming in the future, so keep an eye for those. There's no additional cost to you. They come directly into the package of your community membership. So any new courses that come out or new content comes out, you just get those updates. As well as our Discord, which is always handy to have when you're trying to learn how to be a developer, to have mentors and other people at your skill level that are going through you, where you don't get harassed in Reddit comments or Stack Overflow posts. You actually get people that are supportive and wanting to help you. So you get access to our community, surprise, in the community membership, where you can also bug me for YouTube video ideas, explanations of certain content, or just helping you on your journey. It's nice to have a mentor that's actually supportive and wanting to help you, and not someone that's there just to criticize you and tear you down. But all that stuff aside, again, check the description down below for a link to that, and let's continue on. So we had left off, and I had discussed about how we can actually test our servers, because thus far I've just been demoing it here in the browser, and that's it. But when we begin having to actually add information, meaning if we go to our code base and look at our server API endpoints we have currently, we have one called post levelup, where the purpose of this is going to be not just reading our character JSON file like our GET request does, but also adding to it. And we're also going to talk about the additional service functions we're going to be writing here alongside read data, so this project can actually populate itself and not being dependent on us to write our character JSONs out by hand beforehand, because it doesn't make sense. So, we're going to be messing more with our service and our API endpoints. But at the moment, outside of actually coding out the front end, which I don't want to do yet, because remember, the focus here is to, with examples and a practical build of something, show my students and any YouTube viewers here, the fundamentals of server-side stuff. So we have this post route, but we've shown how the URL bar in the browser acts as a GET request. This GET request we can see in the browser and work with it, and there are various ways we can test a post request, because that's where things are going to change. Right, so I mentioned at the end of the last video, I have Postman installed, but I like all its features, but there's tons of feature bloat. I know they've pissed off the community by forcing registration and things like that. So I wanted to find an alternate for this video series, and an alternate I just may use going forward. For this video series, I have landed on what used to be called Postwoman, which was a less feature or less bloated version of Postman that ran in browser, which is very convenient. Now, I used it years ago, and on a little bit of a rabbit hole, I wound up finding out that, well, they have a redirect on their homepage, that it has moved to something called hopscotch.io. I think it's already going to be in my history here, so let's go ahead and pull it up on my browser. Hopscotch.io. That is H-O-P-P scotch.io. Hopscotch.io. Now, I have already been tweaking with some settings. So on this window, you have this sidebar, you have a workspace collection bar, and you have a request window. Now, I've already logged into my GitHub. I don't think you need to do that, but this is open source. It is free to use, and it's in browser, so it's all very convenient things you can just bookmark as you begin learning server-side development and how to test routes beyond just looking at them in the browser, like we've been doing so far. You don't have to log into GitHub. I just chose to go ahead and do that so I can save any kind of collections and things like that, but that's kind of beyond the scope of this video. I'm not going to show you how to write an entire collections for Hopscotch.io, even though I probably imagine it would work like Postman. But it's a very similar UI, GUI to Postman, so it's a lot of the same concepts. It didn't take me long to start making requests to my server. Now, I uninstalled it, but there is a browser extension you will need to add in order to actually have this website be allowed to make requests to your local host server. So if I run this, you can see I was messing around with refreshes in the browser and checking things out and messing in Postman, or Hopscotch rather, I have to remember to say it correctly. So you can see like my API logging that we talked about in the last video is going haywire because that was me messing with it. So it's just basically this right here, and every time I refresh it, that's what we're seeing right there, more character logs coming from this little middleware from the last video. So you need to, in order for it to be able to communicate to our local host on our computer from the browser, it actually will need an extension. So if you try and click send on your very first go around, it'll even say that it can't send this request until you add the extension. So I'm going to go ahead and click on the Chrome link. It takes me here, so if you're in Firefox, go for that. So sorry for anyone that's not on Chrome or Firefox. If you're on a Chromium browser, you can probably get this working or find an alternative. Always feel free to link in the comments down below if you have an alternative that you prefer compared to this. I'm always open to suggestions, especially if they are open source and free to use without even having to download or log in. Those are my favorites. So we're going to add this to Chrome, and we're going to add the extension for Hopscotch. That way you can actually make requests. Now that I have it added, I'm going to refresh the browser, and we're going to take this default one they have here, echo hopscotch.io, and we get a response, which is exactly what they look like right here. As you can see, it's a giant object with a bunch of stuff inside of it that has various things that can help us. Now, in terms of settings, like I've already picked an accent color. You can see I picked the dark mode background, so it already has my customized theme that I prefer on it. And something you'll need to do is if you install the extension, I don't believe you will need a proxy to worry about here, okay? Now, there are some things to mention. If you go through their FAQs, like I briefly browsed through the FAQs section, and if you get any kind of errors moving forward, I probably should discuss CORS here. So if you get a CORS error or cross-origin resource share error, we can talk about those in an addendum video. Just post in the comments down below if you get them. Now, I tested this on my machine and my Mac laptop running a local Express server without enabling CORS, and Hopscotch was able to query or make requests to it and get responses without having CORS issues. If you get an error that says cross-origin resource share error or disabled or something like that, post in the comments down below, and we're going to add a comment and video that will cover those problems. But I'm not going to cover them if they're not actually going to be an issue, even though they are important to know. But nevertheless, if you have Hopscotch, if you take a moment here, you can pause to like customize your color settings. Make sure your request gets sent through on the default one they give you, the echo hopscotch.io. And for some other customizations, I'm going to click on this bottom left collapse sidebar. I'm going to go to the right-hand side and click on this collapse sidebar on the right hand side, because like I said, we're going to just work with a few tabs here and not actually say them to collections and things like that, because, well, this should be pretty straightforward. So rather than this request here, make sure your server is up and running. For those of you that are probably following along with this series, yours is still running. For anyone that like followed the first video and is waiting for the second video or third video to come out, you may have done something else in your spare time, or again, these are meant to be asynchronous in nature. So maybe you stopped it and picked up the tutorial after dinner on another night. Who knows? Just get your server up and running and get ready to make a request to it. We know that I can see my characters right here at this URL in the browser. So let's see if we can get our server testing tool, our new one we've learned here. Again, this is like the equivalent of something like Postman if you see that online, right? I just looked up 2023 Postman alternatives, since I know the community is kind of annoyed with some of the decisions they've made with Postman. So all I've done is copy the URL that we were testing with in our browser from the previous video into the tab here. We notice here that this dropdown has various HTTP verbs that correspond to the API endpoint verbs that we have been writing thus far: post and get. Then we have our path. Remember, these paths are relative to how we have stacked our routes on each other and where our server is running, which happens to be from the comments that I make my students write to get into the habit of knowing this, of what the relative URL is, and that's going to be where the server is running, aka localhost 3000. So if everything is set up correctly and we click get, you should also see a response of whatever is in your character or character JSON file contents are. If you don't see that here and get a CORS error, if you are getting a CORS error here, again, I couldn't replicate what I expected to happen, which was a CORS error. That's probably because we downloaded an extension that does enable us to do some proxying like that. Because that extension probably circumvents the problem. If you got an error here that says CORS or something like that, here's how you fix it. We're going to install CORS like that, npmi CORS. CORS stands for Cross Origin Resource Sharing. It is an Express middleware. So what we're going to do is we're going to add this middleware by copying this require import line and pasting it on a line below and switching it from the variable express to the variable CORS. Require the library we just installed called CORS. We're going to go to the top level of our list of middlewares. I should probably add it below that middlewares comment and say app.use CORS. There's lots of options you could pass to your CORS with a configuration object. But if you have the error, it should be enough to simply add this CORS call right here in your list of middlewares at the top level for it to be allowed to... Now I made a problem because the browser extension got an error. That's interesting that it caused that there. Oh, because it's not running. I was like, that should not have caused an error. That's why my brain was like, why did an error just happen? Because I turned my server off. But there we go. Yeah, so I saved the file. I'm pretty sure my autosave's on. It is. Save the file, restart the server, and it shouldn't cause any errors, right? So if you did have a CORS error previously, that should get rid of the error. And I think maybe you won't have to install the browser extension and you can just use a proxy with CORS, and it should be good to go. But I mean, just install the extension and go from there and see if it works. If you get a CORS issue, npmi CORS, app import it with a require statement, use it at the top list of your middlewares, app use CORS, invoke the CORS function, and that's it for now. And you should get around those CORS errors over here. Now, that means we are seeing our API response here in our basically server API testing tool, which means I'm no longer limited to what my browser can do from the URL bar, which is a GET request. Now, there are ways we could do this with the command line or code here in our console, but for right now, we're going to use this server testing tool to make us better fleshed out and more developed server developers. So like we had talked about, we have this post request that we need to learn how to actually communicate to. So now we can do that. I'm going to open a new tab, not in Chrome, but rather a new tab here in my requests. You can, and again, these are like JSON or text files that you can basically save. So, you know, in this expanded sidebar button right here, you can actually save them as collections to say Luke's YouTube video, or not Luke, but Covalence's YouTube server video series, and you can save these requests to load between different sessions or things like that. So you can consider doing that. I'm not going to do it here because it'll be overkill for how simple this series is. But let's go ahead and make a new request. Open a new tab. Instead of a GET request, we're going to make a POST request. I'm going to go ahead and it should have like an autocomplete bar of our API, which is localhost 3000. You can actually save them as variables. If it works the same way Postman does, then you can set it as a variable. So we can have something like, instead of having to write this out every time, we could do something like app URL as a variable / characters, which would get us a list of characters. But you can look into that on your own. I'm not going to, because like, you may not use hopscotch ever after this video. So I'm not going to get into a whole lot of in-depth stuff with this testing tool other than how they work fundamentally. So anyway, post request to localhost 3000. Back in VS Code, we had called it the path of /levelup. I'm going to copy and paste this for simplicity. So instead of character, we're making a post request to level up, right? Because this was a get request to character. Post request to level up. We're going to send that request and check it out. We got our response, which is the phrase or the text response body of level up, which is what this is right here. So we know that the API endpoint now exists. It can be correctly requested, and it sends our expected response. Because I see all this, and our middleware should also log our new level up API endpoint request, which is right there, we now know it works, which means it is time to achieve what the original GET request did. We had it make a call to our character service to get some character data and sent that as a response. So now it's going to be time to build out our service file a little bit further in terms of writing data and not just reading it. So let's go ahead to character service. If you recall from the previous video, we have file system, we have path, we have our data path written out and ready to go. We have a function called read data that will read it and try and parse it. And we actually handle a parsing error as well, something I don't do enough of. But remember, you could totally get a problem if the character JSON is incorrectly written or non-existent. It will try to parse something that doesn't exist as JSON, which can't be done, and it'll get an error. So we actually reject with that error should that be the case. So I'm going to go ahead and collapse this function for some space in my visual path here. And we're going to write a new function. Got to center my keyboard. Function called write data, like that. And it's going to be another utility function, so we're going to be adding it to our list down here. Remember, we are doing an ES6 object shorthand where we're actually writing write data as the key and write data as the value. The right-hand side, or write data, corresponds to the name of our variable, or in our case, simply this right-hand side corresponds to the name of the function write data, aka our variable or value. And then the key on this left-hand side, write data colon, is just something we make up. So because I opted to choose a key and value that are the same, I can shorthand it down to the following, and that's a trick you'll see me do all the time. So what we're going to be doing inside of write data is the exact same thing that we have written inside of read data, in that we're going to be running some kind of new promise. So we're not going to be stuck in any kind of bad callback syntax, right? So we're not going to get stuck in callback hell if we're not careful. Same thing, we're going to have access to our resolver and our rejecting functions. What we're going to be now doing is returning a new promise that's going to wrap our fs write file code. We're not doing write file sync, we're doing write file by itself. The write file will take 3 arguments, with an optional 4th one if you need it, but our 3 args are going to be as follows. The first one is our path to our file, aka our path join data path variable we conveniently have written up there. The second is what are we writing? And what we're writing is our data. So basically, what's going to be happening here is we're going to pass in a payload or some data into this function that we intend to write in argument place 2. That's going to be our data. Now, because we are writing what should be JSON data to a JSON file, if I'm passing in a JavaScript array of objects, I cannot write that directly to a JSON file. So what I have to do is take data, wrap it in a set of parentheses, and call JSON stringify on that data instead. Now, there's a trick you can do with JSON stringify, because remember, if we look back in our browser example, this is what JSON actually looks like. It's nothing indented vertically or horizontally because computers do not care about that. Only us humans visually care about that nice vertical and horizontal spacing. There's a way you can make it right that way in this file without having to constantly go into the file and write format. You can do the following: replacer and spacer. So I think that's what they are in terms of args. Replacer and space. Yeah, so this is if you're replacing anything, we're saying, nope, nothing's going to be replaced, and this is how much space you want. So that 2 is a spacer, which means when we write to our JSON file, it'll look formatted kind of like this and not like as a flat line across the page. So our third argument over here is our callback function, right? So there is our callback, just like we had in our read data, where we had and data, and we handled our error. We're gonna be doing the same thing down here in write data. So our callback will have an error if one occurs. And if an error occurs, we're gonna do something very similar. If an error occurs, stop this function dead in its tracks, and also reject with that error if that is truthy. If it's a null or undefined value, aka there is no error, it should not catch this. If there is, it'll catch it, stop it, and reject with that error and not continue any further. Otherwise, let's resolve with some kind of message. Write file successful. That way we have some kind of positive indication, a string value. You could always return with like a Boolean or something like that. Of true, or an object with a message inside of it for yourself. I just want something positive to return, that in case I have to use it in a condition to know if something went right or wrong or something like that, or for logging purposes, I have it available, rather than just resolving with nothing inside of it. So that's it. That's all our promise for write data has to do, is to take this data and write it to file and call it a day. So it's not going to be like amending it in any way. It's literally just going to overwrite that file with our new array of objects. So basically, we're going to have to read the array of objects, modify it in our code, and then rewrite the file in its entirety as our simple way of handling this process, okay? So what we're going to have to do is now begin coding out how our logic is going to work inside of our actual endpoint, because this is just a service file meant to interact with the file system, which means we can keep that kind of stuff out of our server.js. If you recall, we imported everything in that object from character service. So this one right here, module.exports, read data, comma, write data. We imported it into server.js as character service, and character service, like we saw up here, has character service, read data, which returns a promise, which is why we can await it. So I'm going to add the async keyword here on my callback function, or my action of my endpoint. I'm going to wrap it in a try catch, and out of laziness, I'm going to copy the error, the goofy one I had of oops, my code sucks, from this get request, so I have consistent error handling. There's a better way to do this, FYI, where you can just try catch and daisy chain the error along. If you're interested in seeing that, I can go beyond the fundamentals in this video if you are curious. But you can look up other videos on our channel. Just look up Express and Server, and you'll find other videos that show you how to do like global error handling, for example. So now we have an error handler. If that occurs, remember that's the downside of Express and modern async await code, is that it doesn't know how to error handle that, so you have to write it yourself, which can get very tedious. Now, what has to happen is basically we need to pseudocode here, get the character data, or read it, right? So get/read the character data from the JSON file, add the newly selected class to the array, level up a total level, and send a response from the server. So remember, we always send a response. That's what indicates our action is done. Request comes in, response goes out. That's how it works. That's what our pseudocode basically has to be, right? We're going to have to read that data so we can modify it somehow by adding our new class, leveling up, and then sending a response. And just kidding. We have to also write the new data. That's the whole point of this, is not just to read it and modify it. We have to actually write it. So after we modify the data, we're going to write the new data back to the file, so that when we request it again, our website should be in sync and up to date with all the latest changes that happen to that file. And this is also, we're gonna be leveling up our server skills by adding some sanitization, some if statements, some checks to our endpoint here to show you how our server begins to scale up in complexity. Because you're like, well, this looks nice and clean and simple. It can't be much more worse than that, right? It is and can be when it comes to middlewares and authentication and sanitization and parsing, all that kind of fun stuff. It gets kind of gnarly. So the first part is it's actually all fairly simple in all honesty. The hardest part will be understanding how this comes into play. How do we know someone has sent us, and what class they have selected has been sent to our server? That's going to be something a bit more complex. That's going to be body time. We're talking about something called the request body. We'll call it the request body time. Just request body. Time has nothing to do with it, right? So request body, that's where it's going to be a bit more complex, but the rest of it's actually fairly straightforward. Getting and reading information from the file is straightforward. It's going to be the exact same thing we did up here in terms of getting our character data. So I'm going to replace that comment with that right there. I mean, that is how we get our character data, and character data will be a non-JSON version of this. an object with 2 properties, total levels, a number, and classes with which is an array of objects that talk about which class and which level a character is becoming. Remember, in Baldur's Gate, the game ends at level 12 unless you're modding. It goes to 20 then. It can go to 20 or even higher if you want it to, but I don't know. The game's not that difficult, so I don't think you need to go that high unless you're just RPing or having fun in the game. Okay, so now that we have the character data, we need to level up the character and then add the selected class, which will have to be in this order technically, because we want to level up the character so we know what our total levels are, and that's also going to be the new level, right? So basically what's going to happen is this will go to 3, and I'll get errors here because that'll go to 3, and then that way we write level 3 with our new class of maybe rogue as our next level or something like that here, right? So that's what's going to happen. The 2 will become a 3, and we take that new total level and add it in the object and the class I selected. So this will be derived from this property here, basically. So that's what it's going to read from that property to know what level to add here. And the class, that will come from the website. So we can imagine on our website, there's going to be a form with a submit button or level up button. And in the form, there will be a drop down that will have the options of the classes. So the user will select the class and click level up. When they click level up, that will make a request to our server, and that's where this class name is going to come from. So we can imagine rogue is what they picked in the drop down here. This is a terrible drawing, but hopefully it's getting the point across, right? The rogue is what they pick from possibly a checkbox, a radio select. Maybe they write it into an input by hand. In our case, we're going to be coding it as a drop-down option. So they're going to select from a drop-down what class are you adding, click level up, and the number will be derived from total levels. And then the class will come from what they selected on the website. So that's what, again, we'll get to connecting them all together a little bit in the future, but that's what's going to happen. So I'm going to undo my changes here back to 2 and that right there, because we are going to test this with some console logs and act like we're server developers. I'm not going to write out a bunch of code and just say, trust me, it works, bro, and go with it, right? So adding to total levels should be fairly straightforward. Remember, this is representative of character data, the variable, which means we take character data, and all we need to do is the following. Character data.total levels, take its current value, and add 1 to it. So that's going to take total levels, which is 2, and then add 1 and reassign to it, because remember, this is a shorthand to like that. So we're going to take 2, add 1 to get 3, reassign thing to have a new value of 3. That's what's going to do right there, right? So that's going to level up a total level. Then we have to add the selected class. Remember, our character data is the full object. Character data.classes is the array. So if we're going to add that new class in there, it's going to be character data.classes. Classes represents an array. Arrays have a method on them called push to add something at the end of an array. This is how you add an element to the end of a list. So it's going to add it after that right there. Let's hard code an example before I begin talking about how this will be populated and sent to us from a form on a website. We're going to copy this object for simplicity to make sure we don't lose our structure. We're adding a new element to the end of the array, so I'm going to paste it right there. I'm going to remove the double quotes from the class or the keys of our object. It's not important that we do so. My formatter would have removed them for me. I'm a single quotes kind of guy, so we're switching to single quotes on the class there. The class, we're going to replace this eventually with how we get it from a website, but for now, we're just going to make it so it's hard-coded to always be rogue until we learn how to do otherwise. And this level here won't be hard-coded as 2. It'll be whatever this theoretically got modified to be, like we're deriving that value. So we're going to derive the level by saying whatever our current total levels is after leveling up 1 will be what this value should be. And we're going to add class rogue. So that technically takes care of that part there. Now, before I begin any further or keep going any further, let's test this. We can test it in a console log. So we can console log character data to take a look at it. We can also just send it as a response. Message testing. And then send the character data. Remember, this is character data : character data. This is me shorthanding it to make it easy so we can test our response to see if it modified it. We have no logic to write the file yet because I want to make sure that the data we're modifying has been successfully modified in the way I think it needs to be before actually writing it to file. So we have a console log we can look at, and we have a response we can just see in the browser if it worked. As of right now, we send nothing to the request other than the request itself, which means we're going to head back to Hopscotch. We have this localhost 3000 level up. Remember, our previous code was just level up. We should have nodemon running on this project. It means it's restarting itself. So we're going to click send. And there it is. So there's our message testing. I expected to see that. And we have our character data property right here. Can I make this any bigger? I like how the bigger I make it, the smaller the window down there gets. That's so aggravating. That's a bit better. But yeah, like there it is. Like there's what I'm looking for. Did it add level 3 rogue at the bottom correctly? And it did. So I click this behind me, vertical, horizontal layouts, because the further I zoom in, it doesn't zoom in on the response structure at all, which is kind of annoying, but it is what it is. So yeah, there is our response. The character data object with level 3 class rogue successfully added. So we now know that it's modifying the data correctly. We can even come take a look at our console log. All right, that's easier to look at. There we go, Luke. I didn't know how to think about that. We have a console log that represents the correct structure. Total levels got added by 1. The class object got added to our classes array, which means we should now be able to write it to file, and should be good to go. So instead of simply console logging the character data or sending that as the response, we can do the following. We can just have a message on our response that says level up successful, like that. Then we have a level up successful comment, and that's it. And again, the response can be whatever you want it to be. It can just be a smiley face emoji. I don't know if that'll work actually, but you can send a message if it's UTF-8 coded, then encoded, then you can have a smiley face response and just call it a day, or just do a semicolon parentheses. It doesn't matter. But I'm sending some kind of successful message object. This is level up successful. This is what it will look like. Let's go back to Hopscotch, send, and that's what our response looks like if we level up. I like that. You can always add the character data there if you think you can use it somehow in the process. But that right there is enough to let us know something happened, just sending a response as a result of a successful request with no error. So we still have to talk about the request body. That's what's going to change here. We also talk about write the new data before we send a response. So what we're going to have to do now is the following. We will need to ask our character service to write data. What data are we writing? The character data I have successfully modified, console logged, and sent a response of. Remember, this is a promise, which means we need to let it resolve before continuing to the next step, which would be sending a response. And there we go. We have now written the data successfully, and we have sent a response. So as of right now, it's still hard-coded to be rogue. Look at our character JSON. It still is the old version here. I'm going to open the browser back to here. Now, let's go ahead and click on level up. I'm going to click level up. Promise constructor cannot be invoked when... Oh, I read a typo. I know what I did. So, classic, instead of having to edit this error out or try and edit the videos where I cut it, I like leaving errors in to learn from them. So, promise constructor cannot be invoked without new. I tried to reference the promise class object without instantiating a new instance of it. That means that I'm trying to reference the object itself and not a new instance of the promise. That means that something went wrong when I wrote my promise, which means we're thinking, okay, where did I write promises? That's my character service file. We know read data works just fine, and write data is the one that failed, which means we definitely have an issue in our write data function. That means I'm going to go look at write data. I look at my promise, and that's the keyword I forgot. It's even written right up here. So I forgot the new keyword in instantiating, making a new promise instance for this function to use. That's why it failed. So I changed that keyword. I come back over here. I click send. We now get level up successful because the promise succeeded. We should be able to go to character.json, and wouldn't you know it, Rogue has been added. And look, Rogue has been added, and the whole thing isn't messed up in terms of formatting. So let me show you what I mean. Let's go back to our stringify. Let's get rid of the null2 part so you can see what it looks like without that little trick right there. I'm going to click on level up in hopscotch, go back to VS Code, check out character.json, and that's what it looks like because remember, computers don't care about all that formatting. So if I format it, it should look nice again. But the null2 trick, undo that, is what makes it right in a legible format, so you and I as developers can quickly and easily test. And look, it's correctly updating. I added another class of Rogue, and it successfully added to level 4. If I add it again, I should have another level of Rogue because that's hard-coded, and it should be level 5. Total level 5. Level 5 choice was Rogue. Let's go! We did it, y'all. So that right there means we have the basics of it correctly written as our endpoint. What we need to do now is discuss how this will come from a form on a website and how it translates to here. So, as of right now, we don't know what a request body is, but it's a way of sending information, think form data most typically, to an API endpoint, meaning not only do we make this HTTP verb request post to our path or endpoint on our API of /levelup, we can also send additional information, and there's various ways to do so. If you've ever, go to Google right now. Go to Google. There we go. Go to Google. Type in any search you want. I wish I could zoom in on this a bit nicer. I need to figure out there's like a quick like zoom thing here, but I'm going to go ahead and just copy. Yeah, I'm going to copy the Google URL really quickly up until a point here. So I'm going to copy part of my Google URL. So I went to Google. I typed in something into the Google search. I clicked enter. I looked at the URL bar and I see a correspondence between the URL bar and what I typed in my search here. I'm going to add it as a comment to make it more visible. Search ? Q equals request plus params. These are called request parameters, and that is one way of sending information to an API endpoint that you can access. That's typically less done in post requests, but it's a way of sending info to an API endpoint. Not what we're doing here, but something cool to know how to do. If you have interest in it, comment down below, and I will continue this application build and make it completely overkill feature rich for something that's going to be so simple. But that is a way of somehow taking information on a request that's customized, right? Because so far it's just been /character, /levelup. How do we bring in additional or dynamic information to this endpoint? Parameters are one way. Another way, common of post, put, and patch methods, is the request body, right? A body of information. Think like a registration form. You fill out your first name, last name, optional middle initial, password, confirm password, username, date of birth, age, whatever, right? All that kind of stuff. You fill out in a form, you click a submit button. All that stuff you wrote in that form has to get sent to your server so you can do something dynamic with it for that person. So if you're filling out a form of information and sending it to a server, more than likely it's going to be called a request body. Again, think of it as a body of info you are sending to an API endpoint. Now, as JavaScript programmers, you don't actually have to use only a form. We will be doing that in this video series for simplicity, but if you can write it programmatically, you can code the request body to be whatever crap you want. It can be anything. It can be anything you want to send to your server that happens in the background, that you write yourself, that's done via user interaction. Or to just keep it plain Jane simple, we're going to be doing a form. So, how does a request body get sent to our server? How do we get access to it? Because as of right now, if I console.log request, aka rec.body, we recognize, or rather Express recognizes that, yeah, well, the request could have a property on it called body. Let's see what structure it has or looks like inside of this API endpoint. Right, so I'm going to go to my thing here, click level up, we get level up successful, go to our console log, and we see we got undefined. Now, you also might be wondering, hey Luke, you just clicked level up, and every single time I've been clicking level up, why is my server restarting? This is also why I'm sometimes hesitant to add NodeMon here, but NodeMon is looking for any server-side code changes. What's currently in my server code? This character JSON. Every time I add a new object to this array, this character JSON file updating will make NodeMon restart my project. That is something that won't happen with a node start script, but will happen with NodeMon. So I may have to adjust my NodeMon script to tell it to ignore this character JSON file on updates. That way it doesn't restart my server every single time I update my character JSON file. This is the whole pro and not pro and con, but like trade-offs I talk about to my students about coding, especially in server-side development, but it's honestly about all development. I made a decision for quality of life to add NodeMon. I applied it as simply as I could, but it has the drawback that now I have to begin thinking about what files to ignore or structuring my project in a way that NodeMon will ignore certain file changes, such as my JSON file, and restarting my server needlessly. But if I'm just running Node on my project, so if I go back to just running Node on server.js and I go back to level up, notice what doesn't happen. Level up successful. There is no NodeMon restart. So this is something that wouldn't actually bother us in production, but does in development. So that's about trade-offs. I wanted some quality of life and restarts, but now it means I have to adjust my scripts to make sure it doesn't restart on things that it shouldn't restart on. So yeah, just keep that in mind. The more important part is, look at our request body. It is undefined. Why is it undefined? That is because there isn't one single format that our servers, or any server, this is not just Node Express, it can be any web server you build, there are a number of different ways of sending information to a server, okay? So how do we package a request body? We can write it on our websites. When we make a post request, package the information as JSON, package the information as URL, package it in X way, Y way, or Z way. There's tons of different ways to package up info to send to a web server via an HTTP request. Because remember, that's all that this is doing. It's mimicking like a fetch request from our websites, if you're familiar with those. So there are a number of different ways of sending information, and because we have no interpreter or parser to tell us how to handle that body of information, we just straight up get undefined. Request body is undefined, and this is a classic bug error problem that students will run into all of the time. So how do we handle this problem? We have to hire an interpreter to make the request body usable for us. And you will have to hire an interpreter for any possible kind of request body you want to deal with. So we were wondering what kind of request body packaging oh my goodness, Discord of course is blowing up when I'm not here, when I'm trying to record a video. Hold on. Okay, quick edit back. I had to mute my Discord because of course my D&D Discord, ironically making this D&D project, was popping off and I had to silence it. So we need to hire an interpreter. And you might be wondering, Luke, how do we know which interpreter to hire? You said there's a ton of different ones. Is there one that handles everything? Unfortunately, no. Maybe our server only deals in JSON data. Maybe our server only deals in a different kind of data. So the JSON one would make the most sense, but for simplicity, I'm going to show you kind of the old school way of handling stuff here. Now, in terms of knowing what types, you can Google it, or we can see that there happens to be a tab here in Hopscotch that shows us a tab called body, and this body tab, I have it zoomed down, has something called content type. These are the various ways we can send info on over to our server. Okay, we see JSON is one, application, it's called application/JSON. That's how you know you're dealing with types of bodies. There's one called form data or multi-part form data. You might be wondering, oh, that's how we're going to do it from form data, right, Luke? Well, the old school HTML way of doing it is this one here called application /x-www-form-URL-encoded. So when you submit a vanilla HTML form with nothing else, no code at all, and a button, or like when you submit a form, this is the default type it takes. It's called form URL encoded. It is the body type that we are going to be using at the beginning of this demo, and depending on how far this goes, we might also include JSON because that makes sense if we're building REST APIs, but here we're going to be using form URL encoded only. So if I have that form URL encoded, take a look at what it offers us. In the request body of form URL encoded, we have parameters or keys and values, and we can add more and more and more depending on how many we want. So, okay, I see now. Whatever our form dropdown will have as options, we give it a key, we give it a value that the user selects, and when they click submit form, it can send this information to our server, what class they have selected. So how about we call it selected class as the property, and as the value, we've already been doing rogue. Let's just be consistent and use rogue here. Or no, let's be monk. Let's do monk this time. Sorry, everybody. Let's do monk to change it up for our new class levels. So that's what this request will now look like. So you're like, okay, well, we haven't hired an interpreter yet, but if I modify in the request body, I'm going to stop my server and restart it back on run dev. That way, I know the nodemon changes will mess with our console logs, but it's okay. So we're going to see this console log maybe change. So we now have a request body of this type, form URL encoded. Selected class is the key or parameter. Monk is the value. We're going to click send. We get our response down here, which is level up successful. We go look at our console log, and we still have undefined. Why is it still undefined? Like I said, we have to hire an interpreter, and that is what's called a body parser, aka a new band name. I just called it body parser. So how do we install or hire an interpreter? There are, as you can expect, libraries here. I mean, with cores, I'm going to go ahead and get rid of that because we technically may not need it. So there you go. That was just an example earlier in the video. Now, Express, the library, as a version 4 something and higher. Yeah, we're on 4.18 in this video series. It already has several of the most common body parsers enabled, but they're not enabled by default. They are in the Express library, but we have to add them, surprise, as middlewares to our project. Now, remember, this chain of middlewares and endpoints goes and matches and runs in order from top to bottom. We showed how the express.static middleware, if it's above this logger, won't log requests to that static, aka our HTML, CSS, and JS files. But if it's below, it does log them. Because my two endpoints are below that logger, they will be logged to where they go via this middleware. The same thing holds true for our body parser, aka our interpreter of how information can get passed into our server via requests. As long as it's above where we need to access request body, it will be available. Meaning I can add it directly on the endpoint here. I can say, use the express, and there is one called URL-encoded body parser, and we're going to add extended false here. So we can add it directly on this post endpoint to say, hey, Express, add the body parser called URL-encoded. Remember that keyword, URL-encoded? Right? It parses those bodies and looks at requests for the content type header that matches this type option. That's because it's going to look for form URL-encoded bodies. If it sees it, it'll take this information and parse it for us. And the false and true extended Boolean, I don't know if it's actually required. Let's see if it's, what is the default here? Yeah, it uses two different libraries, the query string library or the QS library. It depends on which parsing kind you want to use. I think one uses like one algorithm versus another. I don't think it's honestly that important. I always see extended false, so I tend to stick to it. So that tells me I should probably look into it further. I know it uses one library versus another on false and true. We're going to stick to false because that's what I've always used and that's what I always seen used. So, express URL encoded object extended key value false. we can add that directly on the endpoint, and let's see if that makes a difference. So let's see if our console log still comes up short. So our server's restarted. I'm going to click send, level up successful, and wouldn't you know it, I no longer have undefined. I have an object of property selected class value monk, which is what I wrote in our hopscotch test. So now we have access to it. But the way we've chosen to write it, if I need the request body in another endpoint, I would also have to remember to include this on that endpoint as well, like a put or patch request, also commonly use request bodies. But if I don't want to have to remember to put it on every endpoint, the better way to do this is to add it, not here. So I'm going to cut this. Oopsie. I'm going to cut it and paste it right above my app post into an app.use as a middleware. That is a better way to handle this. I'm now adding the interpreter before my post endpoint, which means anything written below app.use, express.urlencoded, will now have access to request bodies, but this app get will not. So an even better idea is to move your body parser and interpreter somewhere up above, well, maybe in the list of our given middlewares right here. Add that body parser interpreter at a higher level to make sure it is available at all endpoints below it, which will be the rest of my application. So you know a couple of different ways to add it now, even though this is probably a better idea for the scale and purpose of this project and how we're going to be handling things, right? So with that URL encoded added at the top level, we now have it available at all endpoints below it, including our console log here in this post request. Now, for good practice, I'm going to go ahead and add a comment that represents the expected value right here and the type of or the expected key and value of the object. It'll be an object that has this structure, right? That's what we saw in our console log from way earlier. There it is. And it will be monk or rogue or barbarian or whatever. At the end of the day, it needs to be some kind of string. So that's what this represents. The object with the property I expect of their body. And I can even have like body URL encoded, selected class string. This just gives me as a developer and future developers some commented code to understand what this endpoint expects and what it could do for us. I don't have to do this, but this is good for newbies to add to their endpoint so they know what if they come back after a week and look at their code, they know what's going on here. So if I have access to the request body and a property on it now called dot selected class, if I log that now, let's go back to hopscotch. Let's change it from monk to barbarian. And if I click send, we get level up successful. Check our console log. Oh, I scrolled up, that's why. And if I scroll down, look, we get barbarian logged right there when we log dot selected class. So now we have ourselves this request body parsed into a JavaScript object. It's the same reason in our character service file I have to choose to parse the JSON data into JavaScript and resolve it in order to use it over here, right, in read data. So we parse a request body, we populate it with whatever object properties and values that we think we're going to add. This represents what a user is going to select from a drop-down form we're going to build out probably in the third video. And from there, this selected class, which I should have chose fighter. I have a shirt, as you can see, my camera's reversed, but it says Action Surge Reverse, which is a key feature of fighters that makes them so good, and also a great level 2 dip on a lot of classes in Baldur's Gate 3 that are martial classes. Yeah, so that represents what someone's going to select from a drop-down. And now that we have access to it, I can change class rogue into use the request body. Now, something that's not commonly done, and this is a reason I did it this way. Remember, I wanted to keep my what I called data layer away from my networking layer, aka the API endpoint. You typically want to do the same thing with the request body. I do not want to use the request body directly. Think of it as an object of values to use, but not directly. What are you talking about, Luke? This is a more high-level concept that I'm giving you now for some better code in the future, even though it may not seem obvious right now. So instead of doing the following, instead of replacing class rogue with rec body selected class directly, let's make some new lines here. Instead of putting it in there directly, I want to make a copy of selected class instead. So I'm going to say the following, selected class equals, hey, make a copy of that string. Now I will use my variable instead of the request body directly. This is sometimes called a DTO, or data transfer object, in that you take something from the network layer, the request body in this case, store it or copy it onto an object that acts as the transfer to your data layer, aka our write data. This way, I cannot accidentally alter or pollute my body of information because I'm not manipulating it directly. I will be manipulating the selected class and not the request body. This is so overkill for something this simple, but it's going to give you a good habit now for future development on more complex servers and concepts. So that's all. I'll leave it at that for now. So there we go. Now, it should no longer keep adding rogue levels. How many have I added? Okay, we're still technically under the level cap. We'll talk about that in a minute. But now that I have something other than rogue being hard-coded, I can now successfully test it with something else. We switched our hopscotch test to barbarian. Do so if you haven't already, and try testing with it as well. Okay, let's go look at our VS Code window in character.json and check it out. We've got barbarian. As a matter of fact, we can test this quicker. Let's go add another level here. Let's add a level of fighter. Okay, change the value to fighter. Send. Go back to your get tab and get the JSON response here, and wouldn't you know it, fighter is added right there at the end. And there you go. We have now added a post request. We have learned about the request body, the different kinds we can add here. The different kinds we can add. We talked about URL-encoded. We'll see why this is the default HTML submit, which we're going to learn later. We learned about the keys and values of them. We learned how to alter them and manipulate them. Now, for some more advanced stuff for our server. What happens if the dropdown is incorrectly selected and they click submit? You might be thinking the website should have some checks for that. But let's say the website fails. Let's say we have a friend of ours writing the website and we don't trust them to properly sanitize the inputs. What if they accidentally let someone send a request where they didn't select a class? What happens if the levels for the character already is at 12, right? If the character level is at 12, then this shouldn't happen. And guess what? We're right there right now. So how about we add our first little bit of advanced server development that students begin to go, oh, that's how these checks are probably written. So the website should, we would think the website should have these checks in place as is, but we're not going to make that assumption and have our code crash and burn. So I'm going to add the checks at the server level because I can't trust what a website does. I can't trust what somebody else is going to code. I can't trust what I'm going to code. If it runs on a website, a malicious hacker can, well, use it and manipulate it. So we're going to add some checks to where this is running on our server at the fundamental, again, server level that can't be manipulated by a hacker. So let's go ahead and write our first bit of sanitization or our first bit of slightly more advanced server code. It is honestly not that difficult, but I do think it's like this aha moment for students. So this whole process of adding a level cannot work above level 12, again, for Baldur's Gate 3 purposes. So what we're going to do is we're going to read the character data, and we're going to say, if the character data has a total levels property that is greater than or equal to 12, so if somehow it gets above 12, or it's equal to 12, which hopefully it never gets above 12, if it's anything equal or more than 12, then guess what? We've reached a level limit, so we have to send a new response. We're going to stop this function dead in its tracks, and we're going to send a response. We're going to set a status code of, let's say, 400. I think 400 stands for bad request, if I remember correctly. Bad request. And that will give us an error code that says, hey, dude, you have a bad request because we have reached the level limit. So we could send now a JSON object that has a similar structure to our response. This one had a message, level up successful. We can send a JSON object that says level up failed. And we can also send an error along with it. So the message will say level up failed, and the error message would be level limit reached. So we give ourselves some kind of meaningful error handling. Again, we're kind of making this up. There is no REST rule that says it has to be written this way. Just try and be consistent for a given project. But there you go. There's some ideas. So if the characters reach level 12 or higher, then we got to send a status code that's bad because the level up failed. So let's go ahead and check it out. So I want to add another level of fighter to get to level 13, but we can't. So there's the 400 status code, bad request, message, level up failed, and the error specifically says the level up limit has been reached. So that way, if I go to my character JSON, we notice here that level 13 fighter was not added. So I won't get a second level of fighter and I won't get action surge. But there you go. There's that first tidbit of like, oh, that's like the advanced and the edge case part of server-side development that kind of ramps this up from the simple file system array manipulation. You've done this a lot as a JavaScript developer already, but this is where it begins to add up on the server compared to what you've learned on client side and things like that. So other things to take into consideration is the following as well. If there is no selected class, like if they did not pass this property on the request body, we can say the following. If there is no selected class, we're going to do something similar. I'm going to copy and paste this response, return response. The return keyword's also important. Return response status code, 400 sounds good to me. Message could be, invalid input. Well, that could be the error, actually. The error could be invalid input, and the message will be level up failed. So there we go. We have a consistent message among the level up failing, and the error will be invalid input, right? And the input meaning request body, the form data sent to us. So for example, let's change it from selected class to selected classes, or class with a Z, class, selected class. This should also give us an error. Let's see if it works. And look, this error is the one that fired before my level up error. So that's because we said, hey, the body you sent us does not have the expected properties or values on it. And testing for values is a whole nother thing. I have to say, like, make sure it's also a string. Make sure it's one of the following strings, like an array of possible classes, so people can't make up new classes to add. Like, what happens if they go into their class and they write some gobbledygook, like pizza? It would just take it and add it. So we would have to add even more checks to make sure it's one of the available D&D 5e classes and nothing homebrewed, right? So there's a lot of checks you could add here. And I just clicked on Postman by accident. It's going to open. Go away, Postman. I'm using your alternative. Go away. Okay. So we now have some basic checks on server-side development, right? And you can add your own. Again, put them in a code pen and link them in the comments down below, or even just theory or pseudocode or ideas of what else you might add that would be important to your server. That's how you begin thinking more in server-side development terms. Even better is we could add middleware in between here that might be like level up check that runs the selected class. Make sure selected class is a string. Make sure selected class is one of the available D&D classes. Make sure that character levels up aren't too high, etc., etc., etc. So we can write middlewares in here that help move this stuff out of the endpoint code itself and into middlewares to make it reusable and a separation of concerns. But for now, I think it's good enough to go ahead and code it in one endpoint, get it working, and then move things out later when you understand the workflow. But yeah, we're going to make some changes on our server still. If we talk about the request body, this video is already an hour long, and that's good enough because technically our server is done minus a little bit of refactoring in our service file, because again, if you come and change anything inside of here, which we will be shortly enough, and we mess with it up in the structure, it's going to have some issues. So what we're going to do is we're going to write a quick and final piece of the service file that will help us make this project a bit more well-rounded. So this is beyond server-side stuff. This is what happens if the character JSON file isn't there. What happens if it has the incorrect structure? What happens if it fails to parse and stuff like that? We need to write some kind of code that makes sure that handles that. So I'm going to blast through this. So don't think this is some server-side thing. This is something I'm writing so people that want to clone and run this project doesn't have it crash when they do so. So we're going to write a function called checkDataFile. CheckDataFile is going to return a new JavaScript promise object. That promise will have this callback. The promise args will be resolve rejector functions. What it's going to do is it's going to run a call to fs access data path. Access says, hey, does file system have access and permissions to a specific file or directory? And we can have a series of constants. So there's something called file system, which we've imported via fs up here. We've been using it all along. Fs has a property on it called constants that is an object of constants that have certain codes depending on what access we have to a file. For example, there's one called FOK. Does it tell us what that means? Yeah. Does fs access have visible and calling, can it read and write access to the character JSON file? So this is checking for the existence and can it read it and write it. And it has an error callback if that happens to go incorrectly. So there's our error callback if something goes wrong. Did I delete a curly brace somewhere? Hold on. What did I do? Yeah, I did. Okay, I put everything. So undo some code here. Had a typo. Curly brace. Error. Now we're getting a new line. There we go. That's what I messed up. So yeah, what we need to do is if there's an error, that means it cannot find or doesn't have access to that file. So what I need it to do is then to call write data, right? And you'll notice here that what I want to do now is I want to standardize how my data structure goes. So what I'm going to do is come up here with my other constant variable and make another one called initial data. Be as an object, total levels 0, classes empty array. This is what is our initial structure of the character JSON file should look like should it not be there. So now I have this initial data structure that I can change if I want to in the future, but that's what's going to be my write data. Okay, so that's going to be our write data. Then because we're inside of here, let's go ahead, and I don't have async await syntax, let's just use this. We'll do .then resolve and then catch. If there's an error, we're going to reject that with that error. So instead of having to write a callback with error, reject error, I can just pass a reject function with the catch block error, and it will automatically handle the rejection of that error. Otherwise, we're going to resolve data file created. So it's going to write that file if it got an error when attempting to access it. Okay. Otherwise, if it didn't get an error and it found the file, I want it to read the file. I want it to go to that data path, and I want it to see if it has a reading error or it gets the data. So what I'm doing here is I'm making sure that the data is actually populated, because what if the file exists but has nothing inside of it? So we're going to say if there is a read error, that's going to be a bigger problem. So we're going to reject with the read error, stop this function in its tracks. Otherwise, if the data length of that file is 0, that means we have to write the data again with our initial data and the same thing. So I'm going to copy and paste this write data, initial data, then resolve catch reject into this if statement in case it's not there. That's the if statement there. Otherwise, we're going to resolve data file is valid. Okay, So this is just like a little utility service. We're going to add it to our list here, check data file of our exports. That way we can check for its existence and its correctness. So we have like, it will be written with the correct structure if it's empty or it's not there. And that way, if all these checks pass, we should just get down to this else statement of resolve data file is valid, and that's what we're making sure is going to happen for this project, right? So with that in place, the only place we really need to call it, well, I guess we should be calling it from both our post and get requests, but honestly, I'm going to add it only to my read up here. So let's go ahead and do this. Up here, I'm going to say await character service dot check data file. Like that. So I'm going to add check data file as my character service check data file. Making sure I didn't typo. Check data file. Check data file. When I request a character's info, I'm going to make sure the data file has access and has the structure before I attempt to read and send the data over. So let's go ahead and nuke this. I'm going to delete this contents. That would cause a JSON parse error without that code inside of here. But now that I have that, we're going to get the request. Cannot access character data before initialization. What did I manage to do? Oh, I wrote character data. It's character service, Luke. My bad. I'm getting to the end of the video. Talking for an hour and 10 minutes will be draining on anybody. I forgot to add character service.check data file inside of there. So let's try that again. There we go. Check it out. We now have an empty character that's ready for our website to begin building upon. Let's say they go and choose fighter for their first 2 levels. We're going to level up. Level up as fighter. Let's go get the character data. Look at that. It's adding fighter correctly. Now that I have 2 levels of fighter, let's say we add 2 levels of, I don't know. Yeah, let's do one of my builds. Let's do Ranger. Yeah, Ranger. We'll do 5 levels of that. 1, 2, 3, 4, 5. Subclass is Gloomstalker. Yeah, our subclass of Ranger will be Gloomstalker. Level 5 Ranger gets us extra attack, which is important. And from there, let's go ahead and add 3 levels of Rogue to get a subclass, which will be the Assassin subclass. So there's our character so far. We have a level 10 character that is 2 Fighter, 5 Ranger, and 3 Rogue. Let's go ahead and add 1 more Rogue for funsies because it gets us another ASI. And let's go ahead and add another level of Ranger just to even it out. But we should hit our level cap here, level limit reach. So we have a completed character in our Get tab. That is total levels 12, Fighter for Action Surge, 5 Ranger for extra attack and the Gloomstalker subclass, 3 levels of Rogue for the Assassin subclass, and then 1 level of and then 4th level of Rogue for the ASI, and then 1 extra level of Ranger for level 6 just to even things out. So it's 6 Ranger, 4 Rogue, 2 Fighter is our total subclass, and there you go. Maybe we can add that. Maybe add that for advanced work. Add another property that is your build that will output a string that has max level class / next level class / next level class /. So you have like your total class levels of each. Because as of right now, you can parse the classes array and find that out. That'd be some good advanced work. But there you go. We now also have it making sure that the character service, not character data, correctly checks the integrity of that file before this whole project begins. So the first time someone loads the website, it'll make sure that character JSON file is correctly existing and populating before they start adding classes to it. And that's some cool things to learn on server-side development. So yeah, I'll see you in the next video where we're going to code the front-end part of the website out. I'm going to code out some simple bootstrap styling with a form inside of it. We're actually going to code some client-side JavaScript as well that bridges the gap that also I notice a lot of students have is, okay, I've written all this cool server stuff. I've tested it in Postman, Hopscotch, some alternative. How does it combine to the front end? Do I import my character service code? Do I import these routes somehow? Where do I look for console logs on server versus client, etc.? All those questions will be cleared up hopefully in the next video, which I'll see y'all there. So remember, do all the YouTube stuff, like, comment, subscribe, leave comments on any advanced endpoint stuff you want to add here, on things you want me to talk about in future videos in this series or other series. Check the description for our community link if you have interest in learning to code in our courses or just want access to our community and to chat with me in Discord. But otherwise, I'll see y'all in that next video.